Okay, in this section we're going to be talking about heat. So 6b. So heat is the amount of thermal energy transferred into or out of a system. Thermal energy. So again, the key word is the transferred into or out of our system. So again, heat, it's the amount that goes into thermal energy that goes into a system, goes out of a system. And again, a system is an object or a group of objects you're looking at. So it could be anything really. The standard metric unit for heat is joules, because heat's a flow of thermal energy. Energy is in joules, which is a standard unit. Important to note, heat, it's the amount of transferred energy. Again, I think I just said it. It's the amount of transferred energy, not stored energy. So if you have an object, it can't contain heat. It can contain thermal energy. So it can contain 10 joules of thermal energy, but you never say it contains 10 joules of heat. You could say 10 joules of heat flowed out. You could say 10 joules of heat flowed in. But again, it contains thermal energy, and there's heat flowing out, or there could be heat flowing in. So again, remember, heat is not the same thing as thermal energy. And technically, temperature does not measure heat, because temperature is really a measure of thermal energy. So again, temperature is a measure of how fast those little molecules are moving back and forth. So again, temperature does not measure heat. It's really kind of a measure of thermal energy. So next thing, when two objects are brought together, they are in, it's kind of a physicsy word. We're going to say they're in thermal contact. And heat can flow between them. So let's say you had a hot block and then a cold block. Great. If they're separate, really, they're not really going to transfer heat. But if you bring them together, you're going to cause heat to flow from one to the other. And heat's going to flow from the warmer object to the colder object until they're both at the same temperature. So again, if you have, I don't know, let's say this one's at 10 degrees C and this one's at 0 degrees C. If you bring them together, heat is going to flow out of the 10 degrees C1 into the 0 degrees C1 until they reach the same temperature. And again, we're going to learn later how to calculate that. But again, let's just say you brought the 10 degree C1 in contact with the 0 degree C, and then after a while they're both the same temperature. And that is said to, when that happens, when they reach the equal temperatures, it's said that they're at thermal equilibrium. Thermal equilibrium. So again, that's just a fancy word for saying, the heat's all the heat that, is going to flow has already flowed. They've reached a nice steady state where they both have the same temperature. And the last thing is really to think about what's happening at a microscopic level. So at a microscopic level, what's really happening is if something has more thermal energy, it means the molecules are moving faster. They're buzzing around. So again, these would be in like a hot object. And if you bring them in contact with a colder object where the molecules are kind of just not moving too much, if you bring these in contact, what's really happening is the faster ones are going to bounce into the slower ones, and they're going to transfer some energy. So that's really what's happening. If you looked at it like under really, really nice microscope, you'd see that they're colliding and they're transferring energy. So that's really it for heat. Remember, heat is the transfer of thermal energy. It doesn't really just say how much thermal energy is in something, it's how much is flowing in, flowing out. We have fancy words for saying when stuff's touching thermally and when stuff comes to like a nice steady state, right? Thermal contact, thermal equilibrium. And again, what's really happening at the microscopic level. So that's really it for heat. It's mostly conceptual. There's really not much math. But let's see a problem. Here, problem. So again, please take an attempt at this before I go through it. Again, make sure you take an attempt. Listening to hip hop music or whatever. Okay, we'll get started. So we have a hot metal block and a cold bucket of water sitting on a table. Very exciting. Metal block, cold bucket of water. A, which has a higher temperature? Not a trick question. It's the hot block. So a hot block is going to have, you're going to have all the molecules that are moving faster in the hot block. So it's going to be the block, or the metal block. I'll just say block. B, what direction will the heat flow if you put, so if you put the metal into the water, what direction is the heat going to flow? The heat's going to flow out of the block into the water because they're in thermal contact. It's going to flow out of the higher temperature thing to the lower temperature thing. So it's going to flow from the block to the water. C, if you leave it in there overnight, which is going to have the higher temperature. So if you leave this alone for a long time, basically, which is going to have the higher temperature, they're actually going to have the same temperature. So again, they have the same temperature because what's going to happen is you don't know what that temperature is from reading the problem, but you know it's going to be the same. So if you leave things in thermal contact for a long time, they're going to reach at some point thermal equilibrium, meaning they've reached that nice steady state they don't want to move from. So again, that's if you give it enough time. So again, they're going to have the same temperature if you leave it in there overnight. Okay, that's about it for this section on heat.